Resource management is about protecting our environment while using the Earth's natural resources wisely.
Resource management is a new way of thinking about everyday products and the way we use them. The idea is to make the best use of our energy and raw material resources so that we leave a lighter footprint on the Earth.
Resource management is really all about maximizing the efficiency in the manufacturing process and minimizing the waste when the product is disposed of. If we look at the entire life cycle of a product, you really have to go back to getting the raw materials out of the ground and maximizing the use of those raw materials, minimizing the energy used to make the product, taking it all the way through the fabrication of the product to the final material, and then look at, can that material be recycled, reused, or can you recapture the energy from that final product?
All across the country, recycling has emerged as one of the most popular ways that individuals can participate in resource management. Recycling recovers raw materials that would otherwise go to waste.
Plastics recycling has experienced rapid growth. For example, the plastic soft drink bottle, which has only been in the marketplace since the late 1970s, is being recycled at 42%. That's comparable to the aluminum can at the same point in its history.
Today, most plastics are recycled using conventional technology. After used plastics are collected from consumers, they are sorted by resin type and shredded to a uniform size. Then, they are cleaned, melted under low heat, filtered, and finally shaped into pellets. These pellets are sold back to manufacturers, where they are used to create new products.
Each step in recycling adds cost, and there are many people involved. That's why recycled plastic often costs more than making new plastic. However, we're committed to improving the cost efficiencies and reducing the cost of recycled resin.
The American Plastics Council has helped develop new automated sorting equipment that will help keep conventional recycling costs down. They are also looking for new recycling technologies to recover those plastics not suited to conventional recycling methods. In order to understand the different ways to recycle plastics, it helps to first understand how plastic products are made.
What the plastics industry does in its production process might be described as a value chain. We take a raw material, let's call it a feedstock, like oil, and then we take that and make it into chemical building blocks to make a plastic resin. And those plastics are then made into useful products, like a bottle or a fiber or a part for a car. Our industry is learning many ways to recycle or recover these products. Conventional recycling can take those products and bring them right back into the value chain at the point where we make products all over again. Some of the newer advanced recycling technologies that we're working with can bring them back into the value chain, either at the building block stage or at the feedstock stage.
Advanced recycling technologies may offer a solution for those plastics that can't be recycled economically by conventional methods. Preliminary studies have shown that it is possible to recycle plastics back into their original raw materials. Advanced recycling technologies will complement existing conventional recycling systems. They are an important part of an integrated approach to recycling designed to increase the amount of plastics diverted from landfills and turned into valuable new products. Two recent initiatives in advanced recycling involve using heat and alcohol to reverse the process of manufacturing certain plastics. It actually turns them back into their original building blocks.
Methanolysis or glycolysis are a term to describe breaking the polyester materials back into their building blocks to start the production chain all over again. We think these kinds of advanced recycling technologies may be a lower cost way to recycle certain kinds of plastics.
An example of this kind of technology can be found in soft drink containers. Several companies now sell soda in bottles produced in part from plastic that has been recycled using these advanced technologies.
Well, methanolysis and glycolysis are just one more part of the big picture for plastics recycling around the nation. And we're really excited about those two new processes. They do have advantages associated with them and disadvantages, one of the disadvantages being that it requires a tremendous amount of sorting. Sorting is always labor intensive. Additionally, you can only do one resin at a time, and again, that's very costly because it requires sorting to do that. But again, it's part of the breakthrough technologies that we're doing around the country, and that's very exciting.
In Chehalis, Washington, near Seattle, a man named Bill Conrad is betting that he has a solution at hand. A demonstration program is underway here that could add another option to plastics recycling technologies. Conrad Industries is working closely with the American Plastics Council on an advanced recycling process that reclaims a wide range of plastics, turning them back into the raw materials from which they were made.
The advantages of the Conrad system are you don't have to sort, you don't have to clean, and you can use mixed resins, and that's very exciting. Additionally, it's very similar to the recycling systems that aluminum, glass, and steel have been using for generations.
The Conrad system can recycle a number of plastics that to date have not been economically recycled, like yogurt cups, margarine tubs, and multi-layered bottles. By increasing the quantity and variety of plastics that are recycled, we conserve more of the raw materials used to make them. The Conrad system works like this. Plastics are heated and vaporized in the absence of oxygen, which prevents combustion. This process is called thermal depolymerization. Once vaporized, 70 to 80% of the reclaimed plastics are converted into liquid petroleum products, the raw materials of plastics and many other products. A small amount of carbon is also produced in the process, as well as a light gas, which is used to heat the recycling unit. Nothing is wasted.
Well, the two products recovered from this advanced recycling technology are oil and carbon. Oil can go back to a refinery where it can be made into multiple products, one of which is plastics. The carbon could go back into applications and revolving around the use and activation processes for water and wastewater treatment, and also can be used in rubber and plastic products as a filler and reinforcer. So they both have multiple uses and great utility from a recycling standpoint.
I'm proud to be a part of this, proud that maybe we can eliminate some of this waste going to landfills, and so maybe some of my grandchildren won't have to mine some of those landfills. That's why I'm so proud of what we're doing.
Another great advantage of this process is that we do not have to sort plastic streams coming in. It's very tolerant of a mixed, dirty plastic stream, so we only have to shred it before we feed it into our system. This process has no waste products at all, and that's another advantage of advanced recycling technology. For every pound we put in, we have a pound recovered that has utility and value.
Integrated plastics recycling. Conventional and advanced recycling technologies working together. It's an important part of effective resource management, a way to make the best use of our energy and raw material resources, to reuse rather than waste, and to leave lighter footprints on the earth.